Your brain contains a hidden army, a dedicated team of microscopic janitors and guards, constantly working to keep it clean and safe. But in the 55 million people living with dementia worldwide, that army has gone rogue. Instead of protecting the brain, they begin to destroy it. For decades, we've been fighting the wrong enemy. Now, a stunning breakthrough is allowing scientists to take control of that army and turn them back into the heroes they were meant to be. For generations, the story of Alzheimer's has been a story of plaques and tangles. We've all seen the images, sticky clumps of a protein called amyloid beta accumulating between neurons, and twisted strands of another protein, tau, building up inside them. The prevailing theory, known as the amyloid cascade hypothesis, was simple and elegant. These plaques are the primary villains. Get rid of them and you stop the disease. This idea launched a multi-billion-dollar, decades-long pharmaceutical war. Drug after drug was designed to blast these plaques out of the brain. But the results have been, to put it mildly, devastatingly disappointing. Time and again, drugs that successfully cleared plaque failed to stop or even significantly slow the relentless cognitive decline. It felt like we were winning battles, clearing the battlefield of debris, but still losing the war for the patient's mind. This string of failures forced a painful question. What if we've been looking at the problem all wrong? What if the plaque isn't the cause, but merely a symptom of a deeper, more fundamental breakdown? To understand the new frontier, we need to zoom in, past the neurons, past the plaques, and look at the brain's resident immune cells, the microglia. Think of them as the brain's multi-tool. They are the janitors, cleaning up cellular debris and misfolded proteins. They are the paramedics, tending to injured neurons. And they are the security guards, defending against pathogens. In a healthy brain, microglia are heroes, meticulously maintaining the delicate neural environment. But Alzheimer's disease corrupts them. In the presence of factors like the APO4 gene, the strongest genetic risk factor for Alzheimer's, and the constant irritation from plaques, these cells switch from a protective housekeeping state to a chronic inflammatory state. They stop cleaning and start attacking. They spew out inflammatory molecules that damage surrounding neurons, creating a toxic, self-perpetuating cycle of destruction. The janitors have become vandals. This is the neuroinflammatory model of Alzheimer's. The idea that the brain's own immune response is a critical driver of the disease, not just a bystander. This is where the engineering begins. If Alzheimer's is like a corrupted software program running on our microglia, could we write a patch? Researchers at institutions like Washington University School of Medicine are doing exactly that. They've discovered that they can reprogram these rogue microglia back to their healthy, protective state. The key isn't a sledgehammer to destroy plaque, but a precise code to change the cell's behavior. In one groundbreaking study, scientists used a custom-developed antibody to activate a specific protein on the surface of microglia. Think of it as a key for a hidden lock. When this protein was activated, the microglia underwent a profound transformation. Their genetic programming shifted. They ramped up their ability to clear away not just amyloid plaques, but other harmful debris, without triggering that damaging inflammation. In mouse models of Alzheimer's, the results were staggering. Not only were existing plaques cleared with remarkable efficiency, but the microglia also helped reduce damage to the surrounding neurons. They were no longer just eating plaque, they were actively healing the brain. We are not just clearing rubble, we are repairing the cleanup crew itself. The implications of this shift are difficult to overstate. We are entering a new era of neuroimmunotherapy. Instead of carpet bombing the brain to remove a single protein, we can now fine-tune the brain's own powerful maintenance systems. This approach offers several incredible possibilities. First, it could be a treatment. By reactivating the microglia's cleanup function, we might be able to halt or even reverse the progression of the disease in those already diagnosed. Second, it could be a preventative. For the millions who carry high-risk genes like APOE4, a future therapy could keep their microglia in a healthy state, preventing the disease from ever taking hold. It's the difference between waiting for your house to flood and then mopping it up, versus fixing the leaky pipe before it ever breaks. This is no longer science fiction. The antibodies and small molecules used in these studies are being developed with human trials in mind. While the road from a mouse model to a pharmacy shelf is long and challenging, the path is now clear. We are looking at a future where a diagnosis of Alzheimer's isn't a death sentence for your memories, but the start of a treatment plan to restore your brain's own health. For decades, we fought a war against the symptoms of Alzheimer's. We now know the real fight lies within the brain's own immune system. By reprogramming our cellular guardians, we are not just finding a new way to fight an old disease, we are learning to speak the brain's own language of healing and repair. It's a fundamental shift that brings hope where there was once only resignation. If you want to stay ahead of the curve on the technology shaping our world, make sure to subscribe to Decoded Future and hit the bell icon. Our next documentary investigates the race to build the first quantum computer that can actually solve a real-world problem. You won't want to miss it. The future, arriving sooner than you think. The future, decoded.